Okay, this is the another model in time domain analysis. Okay, in this question we have a unity feedback system and forward path gain g of s. Here, the open loop transfer function is nothing but g of s h of s equals to k by s into st plus 2. Okay, so if you find a closed loop transfer function, nothing but g of s by 1 plus g of s h of s, then we will get closed loop transfer function k by s square into t plus 2s plus k. Okay, so here the coefficient of s square is t. To compare this as a closed loop transfer function with a standard second order transfer function, the coefficient of s square must be 1. For that I am taking a common t, then it will be s square plus 2 by t into s plus k by t. So the final closed loop transfer function is k by t by s square plus 2 by t into s plus k by t. Okay, so the question is first question, the factor by which gain should be multiplied to increase the damping ratio from 0.15 to 0.6. Here the damping ratio is increased from 0.15 to 0.16. Let it be this is zeta 1 and this is the zeta 2. If you increase the zeta value from 0.12 to 0.16, 0.6, then the gain value k, the modified value of k is, okay, so we have to find the modified value of k. For that I am comparing this a closed loop transfer function with a standard second order transfer function. So here the denominator is omega square is nothing but k by t, then omega n is equals to under root k by t. Okay, so let it be this is the radian per second. Then if you compare the coefficient of s, 2 zeta omega n is nothing but 2 by t. T get cancelled. Then zeta will be 1 by omega n into t. So here zeta equals to 1 by omega n is nothing but under root k by t into t. So if you simplify this one, zeta value will be 1 by under root k into t. So here t root t, t can be written as root 2 into root t into root t. Okay, root t get cancelled, then the remaining is like this. So let it be equation number 1. So here zeta is function of k and t. So in first question the zeta value is varied from 0.15 to 0.6. Okay, so zeta 1 will be 1 by under root k1. Here the value of t is does not change, only the value of k is changed when the uh, damping ratio varied from 0.15 to 0.6. Here we are keeping the value of t as constant. Then zeta 2 will be 1 by under root k to t. Then what will be the z2 by z2 by zeta 1, then 1 by under root k2t by 1 by under root k1t. So zeta 2 by zeta 1 is equals to, here tt get cancelled, then k1 by k2 under root. Okay, square on both sides, then you will get zeta 2 by zeta 1 whole square is equals to k1 by k2. Okay, so here zeta 2 value is 0.6 and zeta 1 value is 0.15. I'm right? I think it is, yes, correct. So here zeta value is varied from 0.15 to 0.6. So substitute these values, then 0.6 by 0.15 whole square is equals to k1 by k2. So this value will be 0.6 by 0.15. It is a 16. 16 equals to k1 by k2. Then what will be the k2? K2 equals to k1 by 16. Then sorry, k2 equals to 1 by 16 value is 0.0625 into k1. Here k1 is nothing but k. Here k1 is nothing but k. So if you vary the damping ratio from 0.15 to 0.6, then the k value must be varied from k to 0. From k to 0.0625 times of k. So this is the answer for first question. Then what is the second question? The factor by which the time constant k should be multiplied. So to reduce the damping ratio from zeta 0.8 to 0.4. Here zeta damping ratio is reduced from, for second question, here zeta 1 value is 0.8, zeta 2 value is 0.4. Damping factor has been reduced here. Okay, then what is the change in time constant capital T? In this case we are keeping the value of k, gain value k, as constant. Then zeta, we got zeta equals to 1 by under root kt. Okay, then zeta 1 will be zeta 1 will be under root k into t1, zeta 2 will be 1 by under root k into t2. Then z2 zeta 2 by zeta 1 is equals to 1 by under root k t2 by 1 by under root k t1. So if you simplify this equation, zeta 2 by zeta 1 equals to t1 by t2 under root. So zeta 2 by zeta 1 whole square, if you square on both sides, then t1 by t2. So here zeta 2 value is 0.4 by 0.8 whole square is equals to t1 by t2. The value of zeta 4 by 8 whole square, it is 0.25. Okay, 0.25 equals to t1 by t2. Then t2 equals to 4 times of t1. Here t1 is nothing but t. Okay, so if you change the damping factor from 0.8 to 0.4, the time constant must be 4 times of initial time constant t. So this is the answer. Okay, clear?